Today we are going to discuss the next unit that is there in your syllabus, which is called the quadratic equations. So we'll be talking about quadratic equations in the next few discussions. So let us start off the discussion. What basically is a quadratic equation? We need to understand first of all, before trying to solve a quadratic equation, what do we mean by quadratic equation? So an equation px is equal to 0 where px is equal to polynomial of degree 2, where px is basically a polynomial of degree 2. Now any equation in which px is equal to 0, you will get to understand what we mean by px. Px is basically a polynomial. Poly means more than 2. So polynomial is basically a mathematical expression of degree 2, means the highest power in that particular mathematical expression has got to be 2. So there is nothing like cube there. Cube is basically when some variable's power is 3. So the highest power is going to be only 2, and the highest power is also called degree, and that is why we have mentioned here that px is a polynomial of degree 2. So px is going to be a mathematical expression with highest power equal to 2. Then if this px is equal to 0, this would be a quadratic equation, right? Now let's have a look at what is the standard form of a quadratic equation. See, this is the standard form of a quadratic equation: ax square plus bx plus c is equal to 0. Here, one thing that you have to keep in your mind is, first thing, let us understand what are a, b and c's. They are basically coefficients, and x is basically a variable. So there is a term ax square, which means there's a term in which the power of x is 2, x square. You can have a look at ax square plus bx plus c. Then there is another term in which the power of x is 1, and then there is a term c which does not have x as such. So in such kind of equations, ax square plus bx plus c is equal to 0, here for these kind of equations to be a quadratic equation, a should not be equal to 0. Now that is a major requirement. B can be 0, c can be 0. You can have a term with x raised to power 1, or you may or may not have that term. If b is equal to 0, so naturally b, if becomes 0, so 0 into x will be 0. So we would not have any term in which the power of x is 1. Again, c can be 0. So we may not have a term in which there is no x present. If c is equal to 0, then we would not have a term in which there is no x is present, because c is that term in which x raised to the power is 0, or x is not there. X raised to the power 0 is equal to 1. So c is a term in which x has been raised to power 0, and x raised to power is equal to 0, so c will be equal to 0. So if c is 0, it is fine. B is 0, it is fine, but a should not be equal to 0, which means there has to be a term in which the power of x is equal to 2. This is a basic requirement for the equation to be a quadratic equation, right? So now the first line that you have seen here, ax square plus bx plus c is equal to 0, will be a quadratic equation only and only if a is not equal to 0 and b, c can be 0. That's not a problem, and this will be called a quadratic equation in x, right? Now again, it's not necessarily that you'll always get a x, or you'll always have a quadratic equation in x. For example, there can be a quadratic equation in y. Now quadratic equation in y means there should be at least one term in which the power of y is equal to 2, and there should be no term in which the power of y is more than 2. We have seen this. In the first line I told you an equation px equal to 0 where px equal to polynomial of degree 2, and I told you that degree is the highest power. So if you look at ay square by plus c is equal to 0, in this particular equation, this is a quadratic equation in y. What does this mean? There should be at least one term in which the power of y is equal to 2. or there should be at least one y square term. It should at least one y square term should be there. Is this okay? Then only this will be a quadratic equation, provided that there is no other term in which the power of y is more than 2, which means there is no y cube, no y raised to the power 4, no y raised to the power 5, and so on and so forth. Then it will be called a quadratic equation in y. So do you understand the difference between the two? Ax square plus bx plus c. Since x square was there, so this is basically a quadratic equation in x. Since in the second line we have y square, this is basically a quadratic equation in y. Is this understood? And we have also said that b can be 0, c can be 0, which means even if ax square is equal to 0, even then it can be a quadratic equation, because b and c is, if b is equal to 0 and c is equal to 0, bx will be 0, c will be 0, so ultimately it will be x square is equal to 0. This can be a quadratic equation, there is no problem with that. The basic requirement is there should be one term with x square. There should be one x square term if it is a quadratic equation in x. If it is a quadratic equation in y, there should be at least one y square term, and there should be no term with a y cube or y raised to the power 4 or y raised to the power 5. In case of a quadratic equation in x, there should be no term with x raised to power 3, x raised to power 4, and so on. And there should be at least one term with x raised to power 2. Is this okay? So first thing is, a quadratic equation in x will have at least one x square term. A quadratic equation in y will have at least one y square term. A quadratic equation in, let's say, t will have one t square term. And there would be no t cube, no t raised to the power 4, no t raised to the power 5, and so on. Is this understood? So this is how you identify a quadratic equation. Again, a, b, c are basically the coefficients and x is the variable, right? So ax square plus bx plus c is equal to 0. If a is not equal to 0, then it will be a quadratic equation in x, while ay square plus by plus c is equal to 0 will be a quadratic equation in y if there is at least one y square and there is no y cube or y raised to the power and so forth, y raised to the power 4 and so on. Is this okay? Here ABCs are basically coefficients and x equal to variables. What I'm trying to tell you is quadratic equation may not always be a quadratic equation in x or a quadratic equation in y. It could be a quadratic equation in C, D, E. It could be a quadratic equation in H, I. What I'm trying to tell you is that in place of x you can use t, in place of x you can use p, q. So these are different ways of denoting the variables. So you don't need to think that only x or y has to be there. No, it's not like that. You can use any letter to denote variables. Is this okay? It could be s, it could be q, it could be z. Az square is equal to 0 will be a quadratic equation because there is one term in which the power of z is equal to 2 and there is no term with powers of z as more than 2. Is this understood? Right. Now let us take a live example. 2x square plus 5x plus 6 is equal to 0. Is this a quadratic equation? This is what you have to find out. How do you find that out? 2x square plus 5x plus 6 equal to 0. How do you find out whether this is a quadratic equation? See, first thing that you have to do is, now tell me, this is a polynomial, a mathematical expression. What is the degree here? Degree is the highest power in the equation. Have a look, 2x raised to power 2 or x square. So 2x square, or we can say 2 into x raised to power 2. Then we have 5 into x raised to power 1. Here in 5x the power of x is equal to 1. In 6 there is no x, or we can say that the power of x is equal to 0 because x raised to power 0 is equal to 1 and 6 into 1 will be 6. So we can either say that there is no x here, or we can say that the power of x is equal to 0. So x is equal raised to power 0 will become 1 and 6 into x raised to power 0 will be 6 into 1 is equal to 6. So here the highest power in this particular equation is 2, which is there in 2x square term, the first term, which means the degree of this equation is 2. There is no term with x cube, there is no term x raised to power 4, x raised to power 5. This was another condition for any expression to be a quadratic equation. So now we can say that probably yes, this is indeed a quadratic equation. See, degree highest power is equal to 2, we have seen that. Now what you have to do is you have to compare this equation with ax square plus bx plus c is equal to 0. Here when you compare the two equations, 2x square plus 5x plus 6 equal to 0 and ax square plus bx plus c is equal to 0, then you will find out 2x square should be equal to ax square, which means a should be equal to 2, which means a is not equal to 0, and that was a condition for an equation to be a quadratic equation. A is not equal to 0. Again, if you compare bx is equal to 5x, this will give you b is equal to 5 and c will be equal to 6. Indeed, it is quadratic equation. The reason is that a is not equal to 0. Is this understood? You may find problems in understanding this. There is a constraint. We cannot because of the internet connectivity, I cannot use a live classroom, so of course it might be a little difficult for you to understand. It's indeed difficult for me to make you understand also. So what you can probably do is you can pause the video wherever you are finding some problem, just again listen to that particular portion of the video, and then maybe probably you will be able to understand. In case you still find some problem, you can always talk to your batchmates, and then you can always give me a call. Now let us take one more example. 2x square plus 6 equal to 0. Now, what is the degree of this equation? The highest power of x is 2, which is there in the term 2x square. Is it fine? Okay. Now, is there any power of x which is greater than 2? Are there any x raised to the power 3 or x cube terms? Are there any terms like x raised to the power 4, x raised to the power 5 and so on and so forth? No. There are no such terms, which means the highest power in this particular equation is 2. Right? So this is number 1, which means the degree of this equation is equal to 2. And we can say that this particular equation is now a quadratic equation in x, because what has been raised to the power 2? X. That is why it would be called a quadratic equation of x, quadratic equation in x. Now let us try and do the same calculation again. Degree we know already is equal to 2. Now you have to compare it with x square plus bx plus c. Again, when you compare ax square is equal to 2x square, then it should be a is equal to 2, which is not equal to 0. B is not existent here. Bx, there is no term like x here. There is no x term here in the second example, 2x square plus 6 equal to 0, which means b has got to be 0, because when 0 multiplies with x, it will become 0, and that is why here we do not have a term with x, but c will be equal to 6. So this is how you have to compare the equation which has been given to you with the standard equation that we have, ax square plus bx plus c is equal to 0. And since a is not equal to 0, this is quadratic equation. Is this fine? So either you follow this particular procedure which has been shown in the 4 lines that follow the example, or you can simply do it this way. First find out what is the degree of the equation, that is the highest power. The highest power is x square. Is it fine? There should be no higher power, which means x cube should not be there, x raised to the power 4, x raised to the power 5, 6, they should not be there. If these two conditions are satisfied, then again this will be a quadratic equation. So this is other way of saying whatever has been written in these 4 lines, right? The highest power of x, the highest power of a particular equation should be square, and there should not be any higher power terms of x, which means there should not be any cube, there should not be x raised to the power 4 or x raised to the power 5, and this shows that this indeed is a quadratic equation. Well, now I have got a small assignment for you. If you have understood this, what we will do now I'll give you some examples. Now these are the examples. So I've found this particular table for your understanding. You can see that there are 11 examples. The expressions or the mathematical expressions, or what we used to call polynomials, have been given in the second column under the heading expression. The degree or the highest power in that expression has been mentioned in column 3. Then with what are we comparing? That has been mentioned in the column 4. Naturally, if it is an equation with x square kind of terms or x kind of terms, we are going to compare with ax square plus bx plus c is equal to 0. If the expression contains y, we'll compare with ay square plus by plus c is equal to 0. So this is what we have done in the fourth column, and then we have found out the value of a, b and c. And then based on these pieces of information, we have found out whether a particular expression is indeed a quadratic equation or not, right? And then we have also mentioned whether it is a quadratic equation in x or y. So this table is there. Have a look at this table, go through the table. Please try and understand every single example that has been given here, because that will help you better understand what are quadratic equations and to differentiate between a quadratic equation and other kinds of equations. Is this okay? So this is the job for you now. Before I start my next discussion, I expect you all to have gone through this particular table and have understood the table and have understood why a particular equation is being said to be a quadratic equation, or why a particular equation is not qualifying as a quadratic equation. Is this understood? So kindly go through this thoroughly, because, well, this is the first step. In case you are not able to understand what a quadratic equation is, how can you go about solving that quadratic equation? Is this okay? The task for you, as I said, is to go through this table, and in case you find any problem within next 12 hours, you need to send me a message on my WhatsApp telling me which particular expression you are not able to understand. So you can simply give me the serial number of that particular expression. For example, suppose you are not able to understand serial number 4, or let's say serial number 8, you will have to give me this message that you are not able to understand serial number 4 and 8. Is this okay? Right? Thank you very much for your time.